Hello, we're back. We're back to talking about the space program and the Apollo series. And we ended with this. We ended with this Apollo 11 launch on July 16th, 1969. In the capsule, Neil Armstrong, Buzz Aldrin, and Michael Collins. And they are in the command module of the Saturn V rocket heading to the moon. Going to be taking about 3 days to get to the moon or so, 2 to 3 days. And this rocket, again, the most powerful rocket ever created, most powerful machine ever created by humans, still to this day. The launch, I wish I could show you some of these videos. You should look that up. I'll see if I can find something. Just incredible. And this rocket had to be staged, which means this. It means that most of the rocket is fuel. I mean, it contains part of the fuel, liquid oxygen. And when you're done with the fuel in that stage, in that region, you want to jettison the rocket. So the problem is this. The reason the rocket's so big is you have to have a lot of fuel. But if you have a lot of fuel, it's heavy. So what do you need? More fuel. Then it's heavier. So what do you need? More fuel. So that means that you really need to have a rocket that jettisons parts of it when the fuel of that part is exhausted. So that's called a staged rocket, different stages. So this is the first stage after about 40 miles up and getting launched from Florida, Cape Canaveral, Cape Kennedy. After about 40 miles up, it's jettisoned into the water, launched and lands in the water, which we do recover. Now here's staging. You've probably seen this before, staging of a rocket, of this in the Saturn V rocket. Now, look at that. There's that connector between the first and the second stage. And then what happens if the second stage fires and you have fuel in that stage? So here is the Apollo 11 crew, Neil Armstrong, Buzz Aldrin, and Michael Collins. Now, on every Apollo mission to the moon, and this was the first, 2 of the astronauts were going to get to walk on the moon, and 1 was not. 1 had to stay the commander in the command module, while the other 2 astronauts were in what is called the lunar module that heads down to the moon. Now, can you guess, in this one actually, can you guess which astronauts, can you guess which one did not set foot on the moon? Yeah, it's not. Yeah, you see Michael Collins here. Well, I think it just happens to be a picture of him. He's a funny guy. He knew he wasn't going to get to the walk on the moon. It just happened by chance. In this picture, he doesn't look very happy. Now, amazing time in history where we landed on another world, pretty much. Men walk on the moon. Here's from the New York Times. We put a flag there. We put the American flag there. Again, we beat the Russians, right? So, of course, we're going to put an American flag there. If we did it, if we went back to the moon today, there would probably just be, hopefully, a world flag. It would probably be, they're different. Chinese, we're planning on going to the moon again. The Chinese are planning on going to the moon again. Different countries are planning on going to the moon again. It's not as much a contest anymore to do that. Well, we landed on Mare Tranquillitatis, the Sea of Tranquility, the first landing mission right there. And here's the lunar module. The lunar module is within, of course, the Saturn V rocket at the very top of the Saturn V rocket. Not the very top, but right below the command module. So here's the lunar module. This is called the ascension stage, or the descension stage. That's called the ascension stage, I should say. One of the famous footprints on the moon of the first astronaut. Now, it's good to know who the first astronaut was that set foot on the moon. Neil Armstrong. And the second was Buzz Aldrin. Neil Armstrong, number 1. Buzz Aldrin, number 2. Now, I'm going to send you a video that I have to show you of, there are people that still think that we didn't go to the moon. Of course. There's still people that think the Earth is flat. There's still people that think that contrails are chemtrails, and there's still people that think a lot of things. And those people that think a lot of those things don't really think much at all. So, yeah, I'm going to show you about what happened. And we've been to the moon. After Apollo 11, we actually went on Apollo 12 to the moon. Astronauts went, walked on the moon. Apollo 13, there was a problem with. We'll talk about that. But we also went on Apollo 14 to the moon, 15, 16, and 17. 6 missions have been to the moon. Apollo 13 didn't make it. I mean, luckily it got some people back, though. But Apollo 11 and 12, good to know, they landed people on the moon. And then 14, 15, 16, and 17. 6 missions have landed people on the moon. If we were going to fake a mission to the moon, and they actually at the time they said we couldn't have faked it, right? Today with the technology, yeah, maybe we can fake something like that. But back then, going to the moon was easier than faking it. And if we were going to fake it, and if we fooled everybody the first time with Apollo 11, does it make sense? Hey, we fooled everybody. Let's try again. Let's fake it again to see if we can fool everybody. And then if we do it again, let's do it. Don't you think you're going to get caught at some point rather than keep, faking, having these faked missions to the moon? So the people who say there's a moon hoax, they just really don't know much about much. They say that we never went to the moon. The Mythbusters, you trust those guys. They actually had a episode about the moon hoax and whether we went to the moon, and they laid into the moon hoax people. They said, we went to the moon, and this is why you guys are idiots who say that we didn't go to the moon. So, of course, Mythbusters, they're not, you can trust them, of course. The Mythbusters, they figure it out. They know what they're doing. So look, one of the famous pictures of might have been Neil Armstrong, could have been Buzz Aldrin. I think this is a Neil Armstrong picture on the moon. And, the moon hoax people are saying that hey, you'd see stars here. No, you wouldn't. Not if the moon's so bright here that you're going to be a fraction of a second picture. No, you wouldn't see stars. They say other things about a bunch of stuff. The flag. Oh, look, the American flag. You wouldn't see it kind of rippling like this because there's no wind. It proves it's a hoax. No, that's not true. If you start, there's still gravity there. You could still ripple something without wind because the gravity is going to dampen out over time. Yeah, it's just all ridiculous. We went to the moon. We went to the moon 6 times with people. So there's really not much you can argue about that. If you do a little bit of research and if you decide to just go by YouTube and just what people tell you, who knows what you're going to believe. All right. Look, there's seismograph to measure moonquakes. We brought that. We brought the lunar reflector to measure the distance to the moon. We did it on the first mission. Look at this beautiful shot of the Earth. There's a gibbous Earth. And then, so remember we said that the phase of the Earth is the opposite of the phase of the moon. So if it's a gibbous Earth and you're on the Earth looking back at the moon at this time, what would you see? You'd see a crescent Earth. It's opposite. Look at that. Beautiful shot. Famous Earthrise picture. Here we have a nice, just still gibbous Earth from one of the other missions that went to the moon, later missions. Craters, filled with these darker areas called seas or maria. Just some great shots. Here's the ascension stage of the lunar module. It's like a quarter Earth in the background. Here's a command and service module. Remember, one astronaut's going to be in here while 2 astronauts are going to be in the lunar module heading down and then coming back. Great shot of the command and the command and service module. And then here's splashdown. Here's coming back. Everything gets charred. Actually, of everything that comes back that makes it, it's just the very top of the Saturn V rocket. The command module with the astronauts in there. Splashing down, charred because of coming through the atmosphere at many miles per second, all the friction. Luckily, you have a heat shield that protects you. And then getting picked up. And if the first this mission, Apollo 11 mission, the actual aircraft carrier that came and helped, and the helicopter came off the aircraft carrier to pick them up, was the USS Hornet. And the Hornet is stationed in Alameda. You can go there. I've been there with my son multiple times. It's a great place, a lot of history. some spacecraft there, some nice planes, but you can see a part of history going to the Hornet in Alameda, and it's open almost every day. Well, not now, but when you get a chance, check it out. Going to see the USS Hornet, that aircraft carrier. Now, let's talk about this. I'm going to pause for just a second, and we will pause. All right. Well, let's talk about Apollo 13. If you saw the movie, well, I mean, it's a great movie. I mean, you have Tom Hanks. Actually, here's a crew of the original crew of Apollo 13, which are actually the real astronauts. Jim Lovell, one of them. Jim Lovell, Ken Mattingly, and Fred Haise. Well, there's Lovell, Mattingly, and Haise. Lovell was played by Tom Hanks in the movie. Mattingly was played by Gary Sinise, Tom Hanks' buddy. Actually, in real life, he played Lieutenant Dan. You probably know him. He plays in a lot of movies with Hanks. And in Forrest Gump, remember Forrest Gump, Lieutenant Dan? What about Fred Haise? Bill Paxton played Fred Haise. Bill Paxton, you'll know from Aliens, you'll know from Twister, True Lies. But that was the original crew. Now, what happened was this. They're supposed to go up on Apollo 13. Turned out that Mattingly was exposed to someone, I think it might have been Charlie Duke, might have been him, who had the measles, the backup crew. One of the guys had the measles. Now, it turned out that Lovell and Haise had already had the measles. But Mattingly hadn't, and they were afraid that because he was exposed, he was going to be getting the measles on the journey and getting really sick and then wouldn't be able to perform his duties. So they said to Lovell that, hey, you can either scrub Mattingly, have him replaced, or you're not going to get to go on Apollo 13. Lovell had a tough decision to make, but he wanted to go to the moon. He said, okay, let's kind of let Mattingly stay home. And they got someone to replace Mattingly, Jack Swigert, played by Kevin Bacon in the movie. You really need to see Apollo 13 if you haven't. It is totally realistic. It is exactly what happened. Everything in there, I think, was word for word what happened. As far as I know, it was a Ron Howard movie. Ron Howard is great, and it is a great movie. So see Apollo 13. You will get, if you can see Apollo 13, you will. I'll give you an extra point just for seeing Apollo 13. Just for seeing Apollo 13, I'll give you an extra point. Well, now, what happened was this. On the way to the moon, they had to, what happened was this. There was an oxygen tank that got stirred, and there was a faulty coil, and there was an explosion. They actually were losing power, and what happened was they had to use the lunar module kind of like as a lifeboat, and the three of them had to get in there, and they didn't know if they were going to have enough power to get back. They had a problem with the heat shield possibly with this explosion, and luckily they made it back. And look, after re-entry coming to the atmosphere, when they made it back, they almost got burnt up. But look at that. It was charred. The heat shield was just held intact, and so I'm going to pause here for a second. No, I'm not. Don't need to. All right. Now, so the Apollo 13. Look, this was big news when they didn't know if they were going to make it back home, but yeah, they did. It was a testament to NASA and getting them back alive, and just a major accomplishment. Look at some pictures from the moon here. Pictures from the moon. We even took later missions. Apollo 16, 17. We had a buggy. There's a moon buggy on the moon. If you ever get to the moon, there's a buggy waiting for you. I don't know if it's still working, Look at that. Great shot of the lunar buggy. A spacewalk here. See, this movie, In the Shadow of the Moon, documentary about all the Apollo missions. Just incredible. Also, Ron Howard did this, and it was, see this one. I'll give you an extra point just for watching this, too. Now, places we've landed on the moon. It turns out that the Russians also were sending these spacecraft called Lunas. They were getting ready to send someone to the moon, and they actually even had rovers on the moon. So they were about ready to beat us to the moon, but we beat them, finally. But again, it doesn't matter anymore. Who cares who gets to the moon? As long as if people can get there, that's great. That's an accomplishment. And so we need to get back, and we have plans to go back to the moon. We need to get back. Now, 2 types of terrain on the moon. Boy, what do you need to know? One's called Maria. That's good enough. The dark areas, also called the seas of Maria. So write that down, 2 types of terrain. We also have the terre, which is the highlands. So we have the seas, the Maria, and the terre. Good enough. These seas are just, volcanic. Volcanic areas where lava welled up. And surface composition, our surface temperature of the moon, it gets very hot, but it gets very cold. There's no atmosphere on the moon. A lot of impact craters seen, no atmosphere, so everything's going to be striking the moon, nothing gets burnt up. There's some frozen water at the poles in the moon surface, mostly very, very dry. We already saw this, impact areas, different seas, different names of seas and craters. Look, this crater's named Tycho. This crater's named Copernicus. People you know. The Sea of Serenity, Sea of Tranquility, the Sea of Mare Crisium, the Sea of Storms. So great. This dark area, Mare Imbrium, the Sea of Showers or of Rains. You don't have to know any of that. Images of the far side of the moon from the Clementine Global or the Clementine spacecraft. Tycho crater. Here's a rill, a crack. Oh, look at this. You know who's in that basket. You know who this is, right? E.T. But do you know who this is? Tom Hanks. I'm sure none of you saw this movie, Joe versus the Volcano. I like this movie. Meg Ryan, Tom Hanks, one of his 80s movies, more of a comedy. I'll give you a point if you see it. Actually, I'll give you a point if you just can find it. Yeah, well, most people can't even. Joe versus the Volcano. If you can find where it is, show me. I'll give you a point. Actually, yeah, send it to Argyle. Yeah, don't send me that. Make Argyle's really not doing much these days. Send him something to do. I mean, just send him a message. Wake him up. Yeah, he's supposed to. Well, I don't even talk about Argyle now. Look at this great shot. The space shuttle launch with just about a full moon there. Now, here's something I'd like you to know for when we start talking about eclipses. The moon's orbit, now look, here's the ecliptic plane right there. There's the ecliptic plane. The moon's orbital plane is tilted to the ecliptic. It's not the same line as the ecliptic. It's off a little bit by 5 degrees. There's a 5-degree tilt of the moon's orbital plane to the ecliptic. And that is going to lead to why we don't have eclipses each month. We're going to talk about eclipses soon. So a 5-degree tilt of moon's orbit to off the ecliptic. The moon's orbit is tilted by 5 degrees to the ecliptic. Now, something I do want to mention is this: tides. I have a couple names of tides. Now, a tide, again, we talked about tides before. A tide is a stretching force because the gravity is pulling on one side of the body more than the other. Now, when the moon and the sun are in line, they work to stretch the Earth out this way. And we have a spring tide. It's called a spring tide when it's either a new moon or a full moon. New moon or full moon, spring tide, where we have the highest tides. The highest highs, the lowest lows, as the water gets pulled towards the moon, and actually kind of even the sun a little bit. The moon causes greater tides on the Earth because it's closer, not because it has more gravity, but because it pulls on one side more than the other. The sun is far enough away where it doesn't really affect the tides as much, only like 50% as strong as the lunar tides. So a spring tide, we can write this down. Spring tide is when you have the highest high tides, the lowest low tides. Spring tide. And it's during new or full moon, when the moon and sun are working to stretch the earth out this way. And here you'd have a high tide, then 6 hours later you'd have a low tide if you're there. So imagine being here, 6 hours later low tide, 6 hours later high tide. So, but then what happens is this. You also have a tide when the moon is at first, actually that would be third quarter. Here's third quarter moon. We're looking at this with the sun coming from the other direction. At third quarter moon or first quarter moon, the moon is stretching the earth out this way, but the sun is working to stretch the earth out a little bit this way. You have more even tides. It's called neap tide. So while spring tide is during new and full moon, neap tide, where you don't have as high highs, you don't have as low lows, is during first and third quarter moon. That's good to write down. Now, something interesting is the Earth's tidal bulge is actually, the Earth rotates faster than the moon goes around the Earth. I mean, the Earth rotates in a day, and the moon takes 30 days to go around the Earth. Well, because the Earth's tidal bulge is a little bit in front of the moon, it tends to, like, grab the moon or speed the moon up. And because the moon is speeding up, that's why it's moving farther away from the Earth, because it's speeding up. So, and also the moon's gravity is also working on the tidal bulge of the Earth to slow the Earth down a little bit. So the Earth is being slowed down a little bit if you wait long enough. You know, fractions of a second each year. Nothing that you're going to notice very much over hundreds of years. But the moon slows the Earth down while the Earth's bulge speeds the moon up and causes it to start to, it's kind of spiraling away from the Earth. But it would take billions of years for it to really make that much of a difference, so nothing to worry about. Now, there's different ideas about how the moon was created. There's one that it's falling out of favor a little bit, but it was the impact hypothesis, where something struck the Earth and actually caused pieces of the Earth and pieces of the impactor to form into the moon. But I'm not going to test you on that. But something kind of like this, maybe a glancing blow, where this is actually not the moon, but it's another object about half the size of the Earth that we think maybe 4.5 billion years ago or so struck the Earth, and part of the Earth and part of this became the moon. So that's interesting idea. We don't know if that's correct, but that was one of the ideas about how the moon formed. And that's about good for now. It's the second part here, and we will talk about eclipses next time. So take care of yourselves. We'll talk to you soon.